Good morning, children. Today we are going to discuss about inverse trigonometric function. A function is in a function when A is mapped as B, that means B is the image of A. So the inverse of the function will be the A will become the image of B. That means the range will become domain and the domain will become range in the inverse. This way we represent inverse function f to the power minus 1. So to exist the inverse, the function must be bijective or 1 on 2 function. Let's talk about trigonometric function sine x. This is the domain and this is the value of the domain. Say sine 0 is 0, sine pi by 2 is 1, sine pi is 0 and sine 2 pi is also 0. So this is a many one function. You can see the graph also. The value of sine pi by 2 is 1. The value of sine 3 pi by 2 is also 1. The value of sine 3 pi by 2 is 1. Minus 3 pi by 2 is also 1. So this is what? A many one function. So what we say that if we change this codomain to domain and this domain as its range, what will happen? The image of 0 will be 0, pi and 2 pi. So this will not be a function because the definition of the function says every element in the domain must have the unique image in the codomain. So the image of the zeros will be more than 1. Okay. So to make this 1 on 2 function, what we'll do, we'll provide restrictions. We'll provide restrictions and we'll take this branch from like minus pi by 2 to pi by 2. This branch I'm talking about, this branch. Okay. So if you take this branch and you see that in this interval, the function sine x is 1. Every element in the domain is having unique image in the codomain, right? So now sine x has become 1 on 2 function. So sine has become bijective in the interval minus pi by 2 to pi by 2. Okay. So the graph of sine inverse x will be the mirror image of this graph about y equals to x. So the domain will become the range and the range will become the domain. You can see here in this table which I have drawn here for you, the domain of sine x is all real numbers and the range of sine x is minus 1. So the range has become minus pi by 2 to pi by 2 because we have to make this 1 function, and this range is called also principal value branch. Okay, principal value branch means you have to remember this, you have to learn this, everything, that sine x domain, cos x domain and range, tan x domain and range, where so sine inverse x domain will become minus 1 to plus 1 and range is minus pi by 2 to plus pi by 2. Okay. Now similarly cos inverse x range is, cos x range is minus 1 and 1. So cos inverse x domain will be minus 1 and 1. Cos x domain is all real numbers, but cos x principal value, again cos x will be many one function. So to make it 1 function, we have taken this principal value branch. Okay. You can say that we can also take this branch also. Okay. But this branch is acceptable universally. So this value is acceptable all over the world, internationally. So we can say that this range, this branch is principal value branch. Okay. Now you can take a screenshot or note down in your notebooks. Okay, now see the graph of cos x. So the graph of cos x, cos 0 has value 1, cos 90 has value 0, cos 180 has value -1, and a continuous graph. Okay. Now again, this is a many one function. The value of cos 0 is also 1. The value of cos 360 is also 1. So many values you are getting 1. Okay, so to make this graph, make this function, make this many one function to one function, we are taking this branched 0 to pi. Okay, this branch we have taken, and in this interval, in this branch, the function is 1 function, right? So to make this function 1 we are applying restrictions. Okay, so the domain of the cos x is all real numbers, so range is -1 to +1. So the domain of the cos inverse x will become -1 to +1, and the range will become 0 to pi, because in this interval, in this restriction, cos inverse x is 1 functions, right? Note down. Now you see the graph of tan x. The domain of the function tan x is all real numbers except odd multiples of pi by 2, or you can say real numbers -2 and +1 into pi by 2, where n belongs to integer. Because tan x is not defined at pi by 2, 3 pi by 2, okay, odd multiple of pi by 2. Because what is the value of tan 90? Not defined. What is the value of tan 3 pi by 2? Not defined. Because tan x is not defined at 3 pi by 2, so we cannot represent it on graph. So the range of tan x is all real numbers. Again, this is a many one function. So to make this a 1 function, to make it a 1 onto function, to make this inverse function bijective, tan x bijective, so that we can calculate this inverse, so we are applying a restriction, and this restriction is -pi by 2 to pi by 2. So in this interval, pi by 2 to -pi by 2, this tan x is 1 function. So the domain of tan inverse x will become all real numbers, and the range, which is also called principal value branch, is -pi by 2 to pi by 2 in open interval. Why in open interval? Because tan x is not defined at pi by 2 and -pi by 2. Understood? Please note down. Okay, now let's do couple of sums based on the principal value. Suppose we have to calculate the value of sine inverse 1 upon root 2. So what we'll do, first we assume that this whole term is equal to x, right? Now the value of x, because the function is sine inverse x, and we know that the principal value of sine inverse x is -pi by 2 to pi by 2. Okay, that means the value of x, whatever comes, will be in between this interval. So sine inverse 1 upon root 2 equals to x, that means sine x equals to 1 upon root 2. And we know that 1 upon root 2 in sine, it's sine pi by 4. So the value of x will be pi by 4, and which is lying in between this interval. Another example, suppose we solve cos inverse cos 4 pi by 3. So if we assume this as x, so the value of x must belongs to 0 to pi, right? And this value is greater than pi. So cos x equals to cos 4 pi by 3. Now when we have to make this value in between this interval, cos x, we can write 4 pi by 3 as cos 2 pi minus 2 pi by 3. Cos 360 minus theta lies in fourth quadrant, and cos 360 minus theta is cos theta, and the value of 2 pi by 3 is lying in between this interval 0 to pi. It is less than pi, so this can be written as cos x equals to cos 2 pi by 3. So the value of x is 2 pi by 3. Please note down. Okay, now see a couple of more sums. Here we have to calculate the domain of sec inverse 2x minus 3. Okay, if you remember the table, the domain of sec inverse x was all real numbers except the number lying between -1 and +1. Right? So that means mod of 2x minus 3 will be always greater than equal to 1. Okay? So we can write as the value of 2x minus 3 could be positive, could be negative. So when it is negative, the 2x minus 3 will be less than equals to -1. And when it is positive, the 2x minus 3 will be greater than equals to 1. So when you solve these two inequalities, what will get? 2x is less than equal to 2. Transfer minus 3 that side, you will get 2. So x will be less than equals to 1. 2x minus 3 is greater than transfer 3 that side. So 2x will be greater than equal to 1 plus 3, that is 4. So x will be greater than equal to 2. So from here we get the result that domain of the function will be less than 1. Less than 1 means up to minus infinity. From 1 to minus infinity. 1 will be in closed interval. Union greater than equal to 2. From 2 to plus infinity. Right? Note down. Okay, this is another sum from your textbook in which we have to find the value of cos inverse minus root 3 by 2 plus pi by 6. So what we'll do, we'll find the value of this term first. So we'll assume that cos inverse minus root 3 by 2 is equals to say x, and the value of cos inverse x will always lie in between interval 0 to pi, right? So when you solve this, cos x is equals to minus root 3 by 2. Root 3 by 2 is the value of, yes, cos pi by 6 minus cos theta can be written as cos pi minus pi by 6 because cos is negative in second quadrant. So when you solve this pi minus pi by 6, what will you get? Cos 5 pi by 6. And this value is lying in between this interval 0 to pi. So the value of x is 5 pi by 6. When you substitute this value here in place of cos inverse minus root 3 by 2, what will you get? This was the sum. Okay, now put this value 5 pi by 6 here. Plus pi by 6. So 5 pi by 6 plus pi by 6, what will get? I think it's pi. And the value of cos pi is minus 1. So this is the value, this is the answer of this sum. Please copy. Okay, now we are going to discuss some properties of inverse trigonometric functions. Starting from sine of sine inverse x is equals to x, cos of cos inverse x is equals to x, and the sine theta's range is always between -1 and 1. So the value of x will always lie between -1 and 1, or mod of x is less than equals to 1. Similarly, tan of tan inverse x is equals to x, and x will lie between, it belongs to the real number. Cot of cot inverse x equals to x, and so on. Here we can see that sine of sine inverse x is equals to x, and the value of x will be the principal value branch. That means in between minus pi by 2 and pi by 2 closed interval. Cos inverse cos x is equals to x. X will lie between 0 to pi, okay, which is the range of cos inverse x. Now tan inverse of tan x is equals to x, open interval minus pi by 2 to pi by 2. Cot inverse cot x is equals to x, open interval 0 to pi. Sec inverse sec x is equals to x, close interval 0 to pi except pi by 2. Why? Because sec is the reciprocal of cos x and cos is not defined as pi by 2. So if you put sec x, we can write as cos 1 upon cos x, and if you put 1 upon cos pi by 2, it will be 1 upon 0, so this value will be not defined. So accept the value of pi by 2, sec inverse of sec x is equals to x. Okay. Now cosec inverse cosec x is equals to x. X belongs to minus pi by 2 to pi by 2 except 0. Again with the same reason, because cosec x is the reciprocal of sin x and sin x has value 0 at 0 degree. So again it will become 1 upon 0, not defined value. So we cannot have not defined value at 0. We can have, so excluding 0, cos inverse cos x, cosec x equals to x in the interval minus pi by 2 to pi by 2. Okay, note down. Okay, a few more properties, children. Sine inverse minus x equals to minus sine inverse x. Tan inverse minus x equals to minus tan inverse x. Cosec inverse minus x equals to minus cosec inverse x. And cot inverse minus x equals to minus pi minus cot inverse x. Sec inverse minus x, pi minus sec inverse x. These three are same and these three are similar. Let's see how we got this value sine inverse minus x equals to minus sine inverse x. So what we'll do, we are finding the value of sine inverse x as minus sine inverse x. So we assume this value as y. Then sine y equals to minus x, transfer minus that side. So the value of x will be minus sine y. Minus sine theta can be written as sine minus theta. So we write x as sine of minus y. Okay. Now transfer sine that side. So we can write as sine inverse x is equals to minus y. Now what we have assumed the value of y here? Sine inverse minus x. Now substitute the value of sine inverse, substitute value of y here. What we'll get? Sine inverse x is equals to minus sine inverse minus x. Cross multiply minus that side. So we get the value sine inverse minus x equals to minus sine inverse x. Okay, we got the result. Clear to all of you? Okay, children. Now we have to prove that cos inverse minus x is equals to pi minus cos inverse x, right? So what we'll do, we'll assume that let cos inverse minus x is equals to y. So the value of cos y will be minus x. Transfer minus that side. So x will be minus cos y. Minus cos theta can be written as cos 180 minus theta. Cos is negative in second quadrant. So this can be written as cos inverse x is equals to pi minus y. Right. So y will be equals to pi minus cos inverse x. So the value of y when we substitute, that is cos inverse minus x is equals to pi minus cos inverse x. So we got this value of cos inverse minus x is equals to pi minus cos inverse x. Similarly, we can solve sec inverse minus x equals to pi minus sec inverse x, and cosec inverse minus x equals to minus cosec inverse x. Please note down.